Hey guys, how's it going? We've got another question here from a long-time viewer, long-time fan. Let's have a look. We've got a cricketer that was batting, hit a cricket ball such that its vertical height, v meters, after it had travelled h meters horizontally, was given by the rule v equals 1 plus 3h over 5 minus h squared over 50. Sketch the function given that blah. That just tells us our domain where we need to sketch it from. So we begin at 0 and we end at 30. So what's our equation? We have the equation v equals 1 plus 3h over 5 minus h squared over 50. We could think about this as, well, it's just a quadratic, isn't it? And if I wrote it as y equals 1 plus 3x over 5 minus x squared over 50, that might make us feel a bit more comfortable working with it. Now, what do we have to do? We've got to sketch this from 0 to 30. So we can work that out, can't we? I hope so. We need to work out the turning point. So the turning point, that is when x equals negative b over 2a. So what's our b value and what's our a value? Our b value is going to be 3/5, and our a value isn't going to be 1. A is the coefficient of our squared value. So our a value is going to be this negative sign and this over 50. But how can we write that? Well, it's negative 1 over 50. So we can sub those in. We will get x equals... you know what? Let's use the letters in the question given to us. Let's use h. H will equal negative b. So negative 3 over 5 divided by 2, which is multiplied by a half, divided by 1 over 50. So, divided by a. And that's this thing here. So we can multiply by its reciprocal instead of dividing by a fraction. That's pretty gross. So instead of dividing by negative 1 on 50, we can multiply by negative 50 over 1. And if we work this out, we'll get negative 3 times negative 50. That gives us 150 all over 5 times 2 times 1, which is 10. That tells us that when h equals 15, that is where the midpoint is. And would you look at that? That's right in the middle of this, 0 to 30. So that makes me think 0 and 30, maybe those are the x-intercepts. We can find out though. Let's keep going. We've got our h value. We still need v, because h is just, it's the x coordinate. You could think of it as x equals 15. We still need a y value, how high it is, the v value. So we can sub that in. Let's do that now. V equals 1 plus 3 times 15 over 5 minus 15 squared over 50. And I hope you've got your calculators handy, because do I want to work this out? I do. I'll be honest, I do want to work it out. 15 over 5, that makes 3. So 3 times 3, that's 9. Oh, what is 15 squared? I hope you got your calculators out. You better double check my work, make sure I'm doing it right. 15 squared, what is that? 225, I want to say? Over 50. So this can simplify a little bit. 225, it ends with 5, which means we can divide it by 5. So we've got 1 plus 9 is 10, minus this, which is 45 over 10. Oh, we can simplify that a bit further. 10 minus 4.5, which equals 5.5. So we've got a turning point, which is going to be, I'll write it up here. TP is 15, 5.5. And that's our turning point. Do we know the Y-intercept Well, we can work that out. The y-int, where should I do this? Where do I have space? Maybe here. The y-int is when x equals 0, but we've got to be careful. We don't want to mix up v and h. So what we're doing is finding the v-int, and that is when h equals 0. So v will equal 1, because 3 times 0 is 0, and 0 squared is 0. So we've got our y-intercept or v-intercept at 1. So the v-int is going to be 0, 1. That's it. Now, we also want to find out what happens at 30, because that's where we need to stop drawing the function. So we just sub in h equals 30. Sub that in, see what we get. So v will equal 1 plus 3 times 30. Let's finish that 0 off, over 5 minus 30 squared over 50. So v will equal 1 plus 3, what's 30 divided by 5? That's going to be 6. 3 times 6 is 18, minus 30 times 30 is 900 over 50. I can chop off a 0 from both. Can I do 90 divided by 5? I can. Well, I hope I can, at least. That will make it 18. Please feel free to double check this on your calculator. I might be making a mistake on purpose. Or not, you know. 1 plus 18 minus 18, that's just 1. Who would have thought the height will be 1 meter? Because our middle point was 15, and we're doing it 15 on either side of 15. So our height, our vertical height v, should be the same. So we've got our ending point, which is 30, 1. Sketch the function given that blah. So we can finally sketch our function. Now, I can see there's a ruler here. I don't know how to use it, so I'm not going to use it. But you guys probably have a ruler. Please use your ruler. So we're looking from 0 to 30. We know our maximum height is 5.5. That's where the turning point is. Oh, it's a beautiful straight line. I'll put just 30 here. Please use a ruler. I'll put 15 here. Please use a ruler. My height of 1 is here. 2, 3, 4, 5, 6. Let's just draw that up. So 5.5, sorry, 15, 5.5 is just here. 0, 1 is here. I should use different colors, make it stand out a bit. 0, 1 is here. My turning point, 15, 5.5 is there. And 31, 30, 1 I should say, is there. So my parabola, my function, is this. It looks like this. Bam. And that's it. Because it doesn't go any further than 30, and we don't draw it before 0 because of our domain. What was the maximum height reached by the ball? Oh, sorry, we finished sketching it. We've got our turning point. We've got our y-intercept. If we wanted to, we could have calculated x-intercepts. X-ints, that's when y equals 0. And for that, you could use your quadratic formula or the ACB method. It's up to you what you're most comfortable with. And whatever it looks like the question will work with. This one, these numbers aren't nice. Look at the B value, look at the A value. I would probably go with the quadratic formula because that would take me a while to work out. The quadratic formula, I definitely know that'll work. Question B, what was the maximum height? B. Max height. What do we got? 5.5 meters. We already figured that out. Question C. A fielder caught the ball 2 meters above the ground when it was on the way down. How far was the ball from where it was hit? Oh, a lot to think about there. So the fielder, so over here is the batsman, or the batsperson. This is where they hit the ball. And then it flew up, reached its maximum height here, and started to come down. And they caught it 2 meters above the ground. but our function finishes 1 meter above the ground. So we've got to go to 2 meters above the ground and be like, all right, there it is. This is where it was actually caught. And I'm realizing now I didn't draw this X in the right spot. It should be there. Sorry, guys. Don't tell anyone. Anyway, this is where it's actually caught. So we know the Y value, or the V value, and we want to know how far, which is the H value. How can we find that out? That's not too bad. If we let V equal 2, H is something. Now we've got to be careful because we will get two H values. One of them will be over here and one of them is here. We want this one. This is the one we want. Thanks for really emphasizing my point with a nice circle there, Microsoft Whiteboard. C. Let V equal 2. H is something. We got to find it. We'll get two values. We only want that one. Now, you know what? I was going to say I'll let you do the rest of the work, but I'll do a little bit more before letting you guys finish it off on your own. So if I have 2 equals 1 plus 3h over 5 minus h squared over 50, how the heck do I do this? Well, I just need to rearrange it a little bit. Minus 2 to both sides. 1 minus 2 is negative 1 plus 3h over 5 minus h squared over 50. If I look at this, I can identify my a, c, and b values. A will equal not negative 1. A is the coefficient for the power of 2, which is negative 1 on 50. B is just 3/5. And C is negative 1. That's right. It's a quadratic we need to solve. Now, you could use the ACB method. Personally, I would say no. I would just write my quadratic formula down, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And when you're subbing in, don't forget to use brackets. Very important, especially when you have negatives. It just helps keep track of them. Now, I'm not going to do this. I'm going to let you guys do it. But what we do know about this value here that we want to find, we know it should be less than 30. We know that our h value should be less than 30. I don't know, more than 15, probably a safe guess. Maybe more than, 28, 29. We just know a reasonable answer should be less than 30 and more than 15. I'm going to ballpark it and say h is about, 28.5 meters. I don't know. But you guys have a go. See what you get. And thanks for watching. That's all the time I've got. I'll see you next time. Thanks, bye.